Hello students, I am Vamakshi Thakur Singhal, Assistant Professor, School of Pharmacy, BBT University. Here I am going to giving a lecture on buffer solutions, physical pharmaceutics, unit 5th. The agenda of this video is to understand the concept of the buffers, importance of buffer solution in chemistry and in real life, how to calculate the pH of all sorts of the buffer solution, how to prepare all types of pH, what are the type of the buffer solutions, and properties of a good buffer solution. All the points we covered in this video. First of all, the definition of pH. What is the definition of pH? The measurement of the hydrogen ion concentration. The pH is defined as a negative logarithm of hydrogen ion concentration. If the hydrogen ion concentration is very high, the pH value is very low. The pH value is given as a scale ranging from 0 to 40. pH scale is also known as the Sorensen's pH scale. The scale is defined that 0 to 7 gives a acidic solution and above 7 it gives a basic and alkaline solution. The 7 is a neutral pH of the solution. Introduction of buffer solution. Now we discussed about what are the buffer solution and definition of the buffer solution. A buffer is an aqueous solution consisting of a mixture of a weak acid and its salt, as respectively the weak base and its salt. Okay. Its pH changes very lightly, very little when a small amount of strong acid or base is added to it. This is used to prevent changes in the pH of a solution. The buffer solution are used in a wide variety of chemical applications. One of the examples of a buffer solution found in nature is blood. Human blood pH is 7.4. Some people suffer from the alkalosis. In this condition, the pH of blood high is high. So the alkalosis condition where the blood pH is too high. And opposite that condition is where the pH of the blood is lower from 7.4. And that condition is known as the acidosis. The two conditions, one is the alkalosis, second is the acidosis. Alkalosis condition have the pH of the blood is high, and second is acidosis where the pH of the blood is lower than 7.4. Some chemical reaction proceeds only at a certain pH. Many household and cosmetic products need to control their pH values, such as shampoo and the alkalinity of a soap, prevent irritation, baby lotion, baby soaps, and pH of above about 7 to prevent a bacteria multiplying. And also maintain a pH of the washing powders, eye drops, ear drops, all should be a maintained pH before the applicant. Types of the buffer solution. Here we discuss about what are the types of the buffer solution. Basically, two types of the buffer solutions we learned in this video. These are two types, and the first is the weak acid with the conjugate base, weak bases with their conjugate acids. Buffers are a aqueous solution which dissolve in a first type is acidic buffer solution. An acidic buffer solution is simply one which has a pH less than 7. Acidic buffer solution are commonly made from a weak acid and one of its salts, often a sodium. Second is the alkaline or basic buffer solution. An alkaline buffer solution has a pH greater than 7. Alkaline buffer solution are commonly made from one weak base and one its salts. A frequently used example is a mixture of ammonia solution and ammonium chloride solution. A buffer solution has to contain things which will remove any hydrogen ions or hydroxide ions that you might add to it. Otherwise, the pH will changes. The acidic and alkaline buffer solution achieve this a different ways. So, the properties of buffer solution, for the identification, a set, and a good. What are the buffer solutions? So, how to check or how to characterize the buffer solutions? The way the buffer solution is defined a pH. The pH will not be changed over the timing. On the timing basis, the pH value is does not change. On the dilution basis, pH of the buffer solution would not be changed. A slight change pH if a small amount of acid and base is added. And last point, arrange where they are the most effectively. There should be a buffer solutions are characterized of this 5 points. If this all 5 points are followed of buffer solution, that means that buffer solution is a standard and a good quality of buffer solution. So of that good quality of buffer solution we used in a pharmaceutical company or a pharmaceutical products. So for the acidic buffer solution, we will take a mixture of acetic acid and a sodium acetate as typically. The acetic acid is a weak acid and the position of this equilibrium will be shown above the below the equations. Hasselbalch equation where the pH equals to pKa. pKa is the negative logarithm of the acid dissociation constant and the log of the concentration of conjugate base by the conjugate adding of an acid to its the buffer solution. The buffer solution must remove most of the new hydrogen ions, otherwise the pH would drop markedly and hydrogen ion combine with the acetate ions to make a acetic acid. That means a strong acid has been turned to a weak acid. Since the most of the new hydrogen ions are removed, the pH would not be changed very much, but because of the equilibrium involved, it will fall a little bit. Adding a base of this buffer solution, if we add a base in that buffer solution, what are the changes that are observed? Alkaline solution contain hydroxide ions, and the buffer solution removes most of this by reacting with the hydrogen ions to form a water. As soon as this happens, the equilibrium of acid dissociation tips to replace hydrogen ions. This keeps on happening until most of the hydroxide ions are removed. Here the picture of the equilibrium state. The equilibrium moves to replace a H plus ions. And H plus ion is combined with the OH minus ion and liberate a hydrogen, means a water. In this slide, some examples of base synthesis acids with with suitable salts we used for the preparation of a buffer solution. Suppose we formulate or we prepared a acetic acid buffer solution. So for acetic acid, we use a sodium acetate as its salt. Phosphoric acid, we used potassium phosphate as a salt. For oxalic acid, we used a lithium oxalate as a salt. Carbonic acid solution, we used a sodium carbonate as its salt. And last and the least, ammonia, we used ammonium chloride as its salt. There's some examples of the acid and bases which are used to prepare a buffer solution. Commonly, we used ammonia, acetic acid. Both are the common examples. So next, how to calculate the buffer solution and in the acetic acid states. The acetic acid that splits up gives one of each shots of the ions. That no longer true for the buffer solution. If equilibrium has been pushed even further to left, the number of acetate ions coming from the acetic acid, it will completely negligible compare those from the sodium acetate. For example, in above the pictures, the Ka value equals to a CH3COO minus H plus. The both are the two ions no longer equations, no longer equal, is divided by the particular that compound. These are the general equation used for the calculation of pH of a buffer composed of weak salts. So the characteristics of the buffer. Now we come to the characteristics of the buffers. The logarithm of Henderson-Hazelbach equations will be equal to 0. So the pH equals to pK. That means the system can equally absorb acids and bases. If the desired pH is basic, then the weak base plus its salt plus its acid is the most effective. It's the opposite of for the acid as well. So weak acid plus its base. The desired pH is within the buffers. So here I am conclude my video. I am thanking you for giving me your valuable time, and I wish this video will help you.